Okay folks, so in lesson 1 we learned how to solve a first order differential equation. Today we're going to do 2 exam style questions, so very similar to what we did yesterday, apart from its very wordy questions. So this one can be found on page 69 of your textbooks. Okay, so feel free to copy this full example into your jotters if you want, or you can just solve it with me. Okay, I'm not too bothered. Alright, this is actually very appropriate to what we're going through in the pandemic right now. It's pretty cool. So it says here, in a town with population 40,000. Okay, so I'm going to get my highlighter and I'm going to start highlighting all the key points. Okay, so it's a population of 40,000. A flu virus spread rapidly last winter. The percentage P of the population infected. Okay, so that part's important. So the letter P stands for the percentage infected in T days. So T stands for the number of days after the initial outbreak satisfies a differential equation. Okay, so here's a differential equation, that's what we're used to. Right, before I even read part A, I'm going to write down what that differential equation is. So it is dp over dt equals kp. Okay, before I even read the question, I know that I'm able to separate these and then integrate both sides. It's very similar to lesson 1. Okay, so part A, if 100 people are infected initially, okay, so that part's important. Find, in terms of K, the percentage infected T days later. Okay, so I'm trying to find P, pretty much. So this first part here, so it says if 100 people are infected initially, that's our initial condition. So a common mistake here is that people always write P equals 100. Okay, because they think, right, 100 people are infected. That's wrong, okay? Because P stands for the percentage of the population infected. Okay, so P is actually going to be, so 100 people are infected out of a total population of 40,000. That's why I'm doing it as a fraction, because 100 infected out of the total population, and I'm going to times by 100 just because I need that as a percentage. So I'm going to get my calculator. 100 over 40,000 times 100. Okay, so that works out to be a quarter, or I'm just going to work out that in a decimal. I just find that might be a little bit easier to understand in this. Feel free to write a quarter, like 1 over 4 if you want, doesn't matter. So that's that part there dealt with. So if 100 people, so I've done that, are infected initially, so that word is really important there because that tells me what T is. So T is the number of days after the initial outbreak. If this is initially, that's telling me that like it's been 0 days pretty much. So it's telling me that T equals 0 because your time is 0 because it's initially. Okay, so that's your 2 initial conditions. What we're going to do now is what we just did in lesson 1. We're going to separate these two and then integrate both sides. So if dp appears at the top, let's just leave that there. I'm going to multiply both sides by dt. So that tells me what side everything goes to. So I want my p's to the left hand side. So in order to get rid of this p, I'm just going to divide by it. But right, it's a fraction like this. Okay, and then the k here, right, I know that's not a letter T, but k is just a constant, remember, so I'm just going to keep k there. And don't forget about your integral signs. Okay, so let's go ahead and integrate this. So 1 over p, if you've ever got a fraction, do recheck if it's the special case. So if you differentiate the bottom with respect to p, you just get 1. That's what I've got on top. So happy days, it's just ln of the bottom. Easy. So go on to the right hand side. So if we integrate this, now don't assume you're just going to increase the power and divide by the new power, because we're not. Because I'm integrating with respect to t. So think of the letter k just like a number. Think of that as like 2. So if you were integrating 2, you would get 2t. So think of that as a number. The integral of that is just going to be kt plus c. Alright, so let's rearrange to get p by itself. So the only way to get rid of this ln is by doing the opposite, which we learned in the last lesson is the exponential. So I'm going to take e's on both sides. Just like this. And the whole point of doing that is so I can cancel off my e and the ln. So it leaves me with p on this side, which is what I want. And then remember what we did in lesson 1 for this? I could split them up, and then e to the c was just a constant, and we wrote that as a letter A. So e to the c just turns into the constant A, and then you've got e to the kt, obviously. Okay, so that's what we call our general solution. And then what we're going to do is sub in these initial conditions. Okay, so I'm just going to write a note here again. So when p equals 0.25, t equals 0, and that's just taken from the question. So I'm going to sub those two values into this. So 0.25 equals AE, so it was to the power of KT, but if T is 0, K times 0 is just 0, pretty much. And you should know from National 5 that anything to the power of 0 is just 1. So A times 1 is just A. So hence we've now worked out what A is going to be. So A is 0.25. Okay, so I'm going to sub that back into the general solution up here. So that's going to give me P equals 0.25 e to the power of kt. So that's now what we call our particular solution. So I'm just going to get my highlighter and highlight that because that's important, because we're going to be using that in part B as well, I assume. Alright, so that's part A finished. So part A was just asking for find, in terms of K, the percentage infected T days later. So I've got that. I've got the percentage infected T days later. Okay, right, on to part B. Okay, quite a lot is given just in the first line here. So given that 500 people have the flu after 7 days, that tells us something. Okay, so very similar to what's up here. Right, so I'll just go down a bit. I'll change my colour as well for part B. Okay, so it says if 500 people were infected after 7 days, I'm sure. Yep, so that's telling us that T equals 7, because it's after 7 days, and that P, so if 500 were infected, so it's 500 out of a total population of 40,000, times by 100, because I want it as a decimal. That's going to give us what P is going to be. Then once you get those two values, what I want you to do is to sub it into the bit in yellow that I've highlighted. So I'm just going to get my calculator and work out what P is. So that works out to be 5 over 4, but as a fraction, sorry, as a decimal, it's 1.25. So I'm going to sub those two values into the bit in yellow and just see if we can work out anything else. So I am going to have 1.25 equals 0.25 e to the power of kt. So we know that t is 7 here, so it's going to be 7k. Right, now what we've got here is now an equation, and the only variable we've got is that letter k, because e is just a number, isn't it? It's just an exponential, so it's just k. So I'm going to do a little bit of rearranging to get k by itself. So let's start by dividing by 0.25 on both sides. So I could do that without a calculator. I know that goes in 5 times over here. So we get something like this. Okay, so we need to get k by itself. I want to get rid of this bit exponential. The only way of doing that is by doing the opposite, taking ln's on both sides. So ln 5 equals ln e to the 7k. The whole point of doing that is because this ln and e's are opposite, so they cancel. So it leaves me with ln 5 equals 7k. Quite easy, just divide by 7 now to get k by itself. Okay, so we've now worked out what k is going to be, ln 5 over 7. So I'm going to go back up to that part that I've highlighted in yellow and then change k for ln 5 over 7. So p equals 0.25 e, okay, so k is ln 5 over 7, t is just t. So I'm now going to highlight that because that's now important. You see how I'm just taking each sentence, like one sentence at a time in the question, and just working with what I've got. Okay, so that equation just came from that first line here. Okay, now let's read the second part to that question. So how many more are likely to have contracted the virus after 7 days? So that bit in pink tells you that T, oh, did I say 7 there? So that T is 10 after 10 days, sorry. Quite a long question. So if I go back down to here, from the second part of that question, we know that T equals 10, because how many after 10 days? Alright, so I'm going to sub T is 10 into this and solve. So ln 5 over 7 times 10. Now, all of this you could just type that into your calculator and then work it out, because that's just one big number pretty much. So 0.25, then exponential, so you need to press shift ln for that. So it's ln 5 over 7 times 10. Okay, you should get something that works out to be 2.4915 and so on. Okay, so that's the percentage of the population infected. Now, a lot of folk get to this stage and think, right, oh thank God I found what P is, so therefore I'm finished. Sorry to say, we're not finished yet. So part B, given that 500 people have the flu after 7 days, how many more are likely to have contracted the virus after 10 days? So I want to work out the difference. So 7 days is 500 people. So I'm going to work out how many people this 2.49% is going to be, and then subtract it from 500, and that will tell me how many more people are getting it. Okay, so this is obviously a percentage, so 2.4915 ... that's a percentage, so I'm just going to put that over 100 and then times by the population, which is 40,000. Okay, so I'm just going to set up that my calculator. Alright, so that's going to give me 996.6 people. Okay, but the thing is, you can't get 0.6 of a person here, okay? And we're not going to round up, because you can't just make up 0.4 of a person. So we're going to round down for this. So it's 996 people are infected after 10 days, but it was saying how many more, so just subtract that from 500. That's the wee sneaky part at the very end that gets you your final mark. Okay, so hence, so 996 minus your 500, so that gives you 496 people. Okay, so that's how many more people will be infected between 7 and 10 days. Alright. Finally, that's us finished that question here. Okay, so feel free to pause the video to rewind to anything that was said. Just make sure you understand what we're doing here. Okay, now I've got a second question here as well. So this is not in your textbook, it's just one that I've typed up. Okay, so feel free to pause the video at this point and copy this into your notes jotters. If not, we can just begin solving it. So this one's not as long as the previous one. So, tickets go on sale 30 days before the concert. It's not a lot of time. Over the month, the rate at which the tickets sell can be modelled by this. Okay, so before I read the rest of the question, I am going to write that down. So dp over dt equals t squared over 100 bracket 100 minus p. Cool. Where the percentage of tickets sold t days later after the sale begins is p percentage. So same as the last example, p stands for the percentage of tickets sold and t stands for the number of days after the sale begins. Right, when t equals 0 and p equals 0. Okay, so that's just our initial conditions there. Alright, so before we work out what it's trying to ask us, what we can do here, you should recognise this, that you should be able to split this up. Okay, so deal with this bit first. Your dp can stay there. I'm going to multiply both sides by dt. Just like this. Okay, so your p's need to go on the left hand side. So that's this bracket here. So I am going to divide both sides by the bracket. Right, it's a fraction. So 100 minus p. On your right hand side, that's where you've got the letter t's, so that bit can just stay there. So t squared over 100, put your integral signs in, and that's your first mark. Okay, let's go ahead and integrate both sides. So if you look at this, whenever you've got a fraction, always double check if this is the special case. Okay, so if you look at your denominator, if I was to differentiate the bottom, I would get minus 1, because it's 100 minus p. Do you have minus 1 on top? Well, no, but I can stick a minus sign in there like this. But then I need to stick another minus sign at the front just to cancel that off. So now I've essentially turned it into this special case. So the integral of this is going to be minus, because that's at the front, ln of the bottom, and modulus signs. Okay, so that was just the special case. And here we're integrating with respect to t, and I've got a t here, happy days, so I am going to increase the power and divide by the new power. So I'm dividing by 3, there's already 100 on the bottom, so that's 300 on the bottom, plus c. So you're probably starting to recognise these questions the more that you do them. We need to rearrange to get that letter p by itself. Okay, so before I can take exponentials on both sides, I need to get rid of this negative sign, because otherwise the exponentials will not cancel off. So I'm going to multiply both sides by negative 1. So it's ln of the modulus of 100 minus p equals, if you times all this by a negative sign, you just get negative t cubed over 300 minus c. Now you can take your exponentials on both sides, because you've got nothing in front of the ln. So take e's on both sides. Again, you should start to recognise this. E and ln cancel. So that leaves me with 100 minus p equals, same with this part. Now I know I've got a minus c here, but c is just a constant, so that'll adapt to whatever's in front of it. And we're going to write that as a capital letter A. Just like this. So 100 minus p equals ae to the power of negative t cubed over 300. Right, so let's do a little bit of rearranging. Let's get the letter p by itself. So let's start by, you probably do this in one line, I'm going to do it in 2 lines, subtracting 100 on both sides. And then to get p by itself, just multiply both sides by negative 1. Okay, so if you times that by negative 1, that'll be minus e blah blah blah. If you times that by negative 1, that's plus 100. I'm just going to swap those two sides around. Just because it looks nicer. I don't want to start with a negative sign at the front. Alright, so I've integrated and I rearranged to get p by itself. So that is what we call our general solution. Then we're given our initial conditions in the question, which is rather nice. So we're going to sub them in. So our initial conditions are when t equals 0, p equals 0. So that's just at that part there. So I'll write these in here. So p equals 0 when t equals 0. Okay, so let's sub them into the general solution. So 0 equals 100 minus ae to the power of, now if t is 0, all of that just becomes 0. We already know that anything to the power of 0 is just 1. So this is like 100 minus a. And then if we rearrange to get a by itself, just add a to both sides. A is going to be 100. Okay, so what we're going to do is sub that back into our particular solution. No, sub that into our general solution, so this now becomes our particular solution. So 100 minus 100 e to the power of negative t cubed over 300, and that's our particular solution here. So let's get that highlighted. Question. It's just saying to you, express p in terms of t explicitly. So express p, which I've done, in terms of t explicitly. So that's us actually finished. There's no part B to this question where it's asking for like how many days later, blah blah blah. That's us finished. We've expressed p in terms of t. Okay, so that's lesson 2 finished. It was just 2 exam style questions, and I know they're really long. Lesson 3 is just the exam questions, so please take your time going through that. If you're stuck at anything, there are full solutions on YouTube, or I've got full solutions here written down as well, so I'm more than happy to post them to give you a wee helping hand. Alright.